Alright, we are on homework 4, part D, part 1. Oh, I'll just read all the parts. But generate synthetic data for the response of the process GP equals 1.5 over 7s plus 1 to the third power times 12s plus 1 squared to a step change input of a magnitude of 1.2 over 50 times steps of 2.5 time units. Add Gaussian normal distributed noise with a standard deviation of 0.05 to the calculated response. Well, I already put GP in because I didn't want to do it on camera because that's a lot of parentheses. And so that equals NP sim. We're going to do GP because it's the only thing we have. And then we're going to do lambda T, and then 2.5, what was the step change, not 2.5, it would be 1.2. And then what's next? N equals 50. Right? And then T, dt equals 2.5. And now we're going to do y underscore, what are we going to call this? Data equals np dot random dot normal. Okay, that's scary. But that's basically creating the data. So if we look at y underscore data, it's just random values. We'll just normalize our values. God, I'm hungry. I'm so hungry. Sure. Okay, I didn't want to do that. Anyway. Now we want to fit an FOPD model for data, then minimize the sum square error, and then we're going to compare the two on a chart. But, alright, so we're going to want to do this before here. Code. So define, oh god, FOT, what the heck is it? FOPTD. And we're going to have a lot of things we want to define here, like time, comma theta, comma k. I looked up what an FOPTD thing is, and I can't remember what else we want to define. But I do know, oh gosh, let me just put, we want to do np.where, basically we want something to be bigger than that, like theta is greater than time or something, then k times, oh gosh, this is bad, 1 minus np.exp, it's like t minus theta. I don't remember any of this. Shoot. Maybe this is S. That makes sense to me. Because, like, I was trying to look it up, and it doesn't really come up on Wikipedia, you know? Wikipedia. It does not show up. So if we look at this means nothing to me. I don't even know why I'm watching this on a video. Oh, so we wanted this, like 1 minus, because we have that, minus e to the negative, who knows, but we want something along those lines. And then we're also going to want, we probably want to return this too, huh? Return, I can't spell. That's embarrassing, but return. Oh, thank God. Third time's the charm. So then we're going to do like y underscore model. It's going to equal like FOPTD. Yeah, and then we want to just put numbers in. So like 10, 30, 15, 2, who knows. But yeah. And then y data, and then we want to like, you can get rid of this, I think. We want to like define squared SSE. We're defining, shoot, I don't know what we want to put in here. D, because we can, and we just, I think we just want to return that, well, I don't even know if we want to do a sum, because this might be an, oh, if it's an array, we don't want to do a sum. Is it a vector? Ooh, all right. I have a lot of things I need to figure out what I'm doing, where I am and what I'm doing, so we're going to be back. But we were able to do the first part of whatever this is, the first part of D1, and now we're on D2. So there's a lot wrong. So first we want to do T, K, tau, and then theta. And we also flip this around. We want where T is greater than theta. And then we also want NP, and then we divide it by tau. And then at the end, I think we're going to do comma 0. It might still need to be within parentheses, but who knows. Then here, Y model is going to be T. Let me check this. Shoot. Oh, this is also something I realizing as I was writing this out. We want a vector and shoot. I mean, I'm not going to turn this down, but I'm just going to get rid of that and just Control X, Control V. Oh man, what's going on? And then I need another. Do I even need that? Who knows? But it's there now. Yeah. Again, I don't know if this is right. Doesn't have an error. Probably doesn't mean there's nothing in there. But let's see. Is there anything we could like just put? We're gonna need a v0 array. For essentially, it's gonna be the same thing we're gonna put in here. So, shoot. I'm trying to think what else we need. And we want to change our k value because we're changing our step change. Tau theta. There's something else I need, but I don't remember. So we're just going to do fig equals make underscore subplots. And we got to remember to actually, close the parentheses this time. Then fig dot add underscore scatter. That works. We don't want to show because we have nothing and we're broken. But so y data, and we're going to name it data, and we're also going to do mode equals markers. Let's see if that works. And then mode equals lines. All right. So what we need, what I'm going to come back and fix is we're going to actually have values for this. Double check this is right, and then we're also going to need a few more things in here. But it's looking good. We're making progress. All right, so we can do here numbers you can put in 1.8, 30, and then 15. And then we're going to copy that down here, this same order, 0.8, 30, 15. And then we also want to do, shoot, I'm remember, yes, but I don't think we want method, because I don't even know what that means. And then we do point add dot x, but we also want to put variables here. It would be like ka, comma tau, comma theta, perchance. There's a good chance I'm wrong. And then another thing is we don't want model down here. We're going to want the FO. I want to say we just put variables in. I don't think we actually want to put numbers. So we like t comma tau, t comma which k? comma, tau, comma, theta. Alright, that, because that's just an error, I'm assuming we want to do that. Let's see, I don't think any of this is going to run, but we can try. Return. I am missing a negative sign here, I realized. So we're like that, negative. And then we're going to make that. Alright, I don't know if this is right. But we have something, so like you can see where like the data pretty, I mean, of course it follows it, duh. But still, like I feel like this is a pretty good representation. I will double check that this is right first and foremost, because it's starting at 20. I mean, that is the shift, but still. I'll be right back, and if it's right, we can start 3. If not, I can explain what went wrong and how I'm going to fix it. So I'll be right back. So the reason I was a little confused while looking at the results we had gotten is because usually when I'm doing problems like this, I hover over and I basically base off my answer, on what I'm being given. However, like some of these answers are, like, they're a little bit different, like, or, based them off at 40, or answers are different. And I didn't realize that, but that's because it's based off of our data. Like, creating our model is based off of our data, and our data is random, so our model is going to have a little bit of wiggle room, which is something I didn't think about until it kind of hit me in the face. And like, that makes sense why everything is just a little bit off. It's not exact, but it's very close to the example I've been given. So this actually fulfills part 2, where we fit a FOPTD model to the synthetic data in part D1 by minimizing the sum squared error between model and data nonlinear regression. Which means we can move on to part 3, which is using the fitted parameter in part D2 and the calculated PI controller parameters by Smith and Carupio from 1997, simulate the closed-loop response of the system to a step change in set point. So what he's meaning is we were given all this information and such, which is so big on the screen, it hurts my eyes. But yeah, we were given this example, and we needed to copy some of these numbers down. And these equations. So some of these values were given. So for example, we're calculating TI. It's already wrote it down. Same with calculating Y and D. Because it's taken me a hot second, and I don't think you wanted to watch that. So for example, we have PA, BB, IB, and then K. 1.2 was given above. Was given in here, magnitude 1.2. And then we have Y, which is PA times theta over tau, which is ugly. Then KC, Y over K, equation was given. And then tau I, as I said, equations are all given down at the bottom. I'm so hungry. Then this is all stuff we've calculated before as well. So I believe it is time to start simulating. So we're going to do T, comma, Y new. We'll simulate lambda. We're going to do 1. We're going to do 1,000. This is different. And then dt. I'm just going to do 1. I don't care. And then start fig2 equals make subplots. No, its name is going to, it doesn't need a name. It's just going to be line. It doesn't need a name. What? See, invalid response for type. Okay. The mode property is a flag list, may be specific as a string. Oh, because it's line and not lines. That's really the issue. Alright. And boom shakalaka. I think we get what we want. So what this is showing us is using the parameters basically from the FOPD model, and then these parameters we were given, we were able to then simulate a closed loop response of the system to a step change. Because essentially what we're doing is using some of the values we got up here and the values we got down here, for this specific type of controller, what are we going to get? So what we end up getting is, you can see, goes out, then boom, it's on the money for after not too long of a time, which is impressive, because considering I got 120, 130 were there, and I mean, it's starting to line out, but not nearly as well as I believe this is. But I believe this puts us at an end of homework 4D. So, and homework 4 in general. So thank you for watching. I had so much fun sitting in this room for 4 hours, but